Hello and welcome back. In this video, we'll be looking at some of the fundamental trigonometric identities, and this is for section 5.1 in the book. So to begin with, let's review a little bit about our trig functions. So the sine of an angle, the cosine of an angle, and the tangent of an angle. The way that this works is in order to identify our angle, we pick a point, xy. We draw a line from that point to the origin, and our angle is going to be from the positive x-axis to that line. So this is our angle. Xy is our point up here, and r is the distance from that point to the origin. So the sine of an angle is going to be the height of that point, y, divided by r, the length, the distance from that point to the origin. Cosine is going to be x divided by r, and tangent is y divided by x. The cosecant, secant, and cotangent, we match them up like this, so that each one of these is just the reciprocal of the other. So the cosecant of an angle theta is going to be r divided by y, whereas sine was y divided by r. The secant is again going to be the reciprocal of the cosine, r divided by x, and cotangent is going to be x divided by y, whereas tangent was y divided by x. So this right away gives us some identities, and this is again something that we've seen before. So for instance, the sine being y over r, and the cosecant being r over y, that means that we can simply flip these guys over. So the sine of an angle is 1 over the cosecant of that same angle. Again, it's just a reciprocal. We're just taking that and flipping it over. The cosine being x over r, and the secant being r over x, the cosine is then going to be 1 divided by the secant. Of theta, and the tangent will be 1 over the cotangent. And quite often I think these are written in the other order, so we can do that as well. If the sine is 1 over the cosecant, then the cosecant will be 1 over the sine. The secant of an angle theta is going to be 1 over the cosine. And the cotangent, again, if the tangent is 1 over the cotangent, then the cotangent is 1 over the tangent. So quite often, I in particular really like to work with the first three trig functions. I'd rather work with sines, cosines, and tangents than the other ones, simply because I feel like I understand these guys better. So anytime you see a cosecant, we can just write it in terms of the sine. We can write it as 1 over sine, or secant, you can write it in terms of 1 over cosine. And this, I think, is a good strategy for approaching problems with cosecant, secant, and cotangent in it. Just turn them into sines, cosines, and tangents, and work from there. So these are what we'll call the reciprocal identities. And we also have some Pythagorean identities. So we should remember what the Pythagorean theorem says. The Pythagorean theorem says that if we have a right triangle, the side lengths squared should sum up to the other one squared. So a squared plus b squared is equal to c squared. And there is a hidden triangle in this picture here. I can draw a triangle by adding one extra line there. This is a right triangle. The distance, so the length of this line there is going to be x. That's how far over we are. The distance up there is going to be y, and then the distance along the hypotenuse is r. So we have x squared plus y squared is equal to r squared. So in this drawing, we have this triangle in there, and this allows us to have some identities because we have this relationship between x squared, y squared, and r squared. So the first thing that I'm going to do is I'm going to write down x squared plus y squared is equal to r squared. And I'm going to do the following. I'm going to divide everything by r squared. Why? You will see in a second. So if I divide everything by r squared, I can now simplify this a little bit. So this is going to be x squared divided by r squared. So as I simplify this, x squared divided by r squared, that's the same thing as x divided by r squared. Then I have y squared divided by r squared. Well, that's the same thing as y divided by r squared. Again, if you square a fraction, you square the top and square the bottom, so we get back what we had. So far, so good. And I've got r squared divided by r squared, which is just 1. And now things will start to fall into place, because x divided by r, that's the cosine, squared. And the way that we write the cosine squared, I'm going to put the squared right next to the cosine. Rather than the cosine of the angle squared, it's the whole thing squared. I could write this whole thing squared, but mathematicians will typically write the 2 right next to the cosine. So we know that it's the whole thing, it's the cosine that we're squaring. Y divided by r, that's the sine of an angle, and we're squaring it. And all that is equal to 1. So here is our first Pythagorean identity. Normally we would write it in the other order, just because quite often we think of sine before we think of cosine. I'm not sure why, but it doesn't matter what order you add things. So sine squared plus cosine squared is equal to 1. These are the same identity, just written in the other order. This is our first Pythagorean identity. And there are a few more. So for instance, let's write down our Pythagorean theorem again. So we have x squared plus y squared is equal to r squared. We divided through by r squared, and we got things in terms of sines and cosines. Let's try another one. Let's go through and divide everything by, let's say, x squared. So what happens when we divide everything by x squared? Well, x squared divided by x squared, that's just 1. Y squared divided by x squared, well, that's just going to be y divided by x squared. And then this last one, we have r divided by x squared. Okay, so now we need to know what is y divided by x and x divided by r. Well, r divided by x. X divided by r, that's cosine. So we've taken the reciprocal, and the reciprocal of cosine is secant. So this right here is going to be the secant. And again, it's squared. So again, x over r is the cosine, and then 1 over the cosine, because we've taken the reciprocal, is the secant. So I know that r divided by x is going to be this secant. So it's just some quick scratch work. Y divided by x, well, that was the tangent. And we're squaring that, and then we've got 1. So here is our second Pythagorean identity. 1 plus tangent squared is equal to secant squared. And then the last one, so we divided by x squared everywhere. Now the last one is going to be to divide by y squared. So if I take x squared plus y squared is equal to r squared, so our Pythagorean identity, and I'm going to divide everything by y squared. Again, x squared divided by y squared is the same thing as x divided by y quantity squared. Y squared divided by y squared, that's just 1. And r squared divided by y squared, that's just going to be r divided by y. Okay, so let's go through and simplify these into trig functions. Y divided by x is the tangent, so x divided by y is the reciprocal of tangent, which was the cotangent. We've just flipped over that fraction, so we get the cotangent. 1, well, that's just 1. no need to simplify there. And then the so we have r divided by y. Well, y divided by r was the sine. So this is the reciprocal, and the reciprocal of sine is the cosecant. So here is our third Pythagorean identity. So we have 3. Sine squared plus cosine squared is equal to 1. 1 plus tangent squared is equal to secant squared. And cotangent squared plus 1 is equal to cosecant squared. And again, it doesn't matter what order I add these in. It's just sort of canonical to write it in that order, I think. So we have some ways to combine squares. We have some quotient identities as well. So from before, we know that tangent is going to be y divided by x. And here this is going to seem very silly, but I can multiply both the top and the bottom by the same thing. Why am I doing this? Why am I multiplying by 1 over r? Well, I'll get y divided by r over x divided by r. Y divided by r is the sine. X divided by r is the cosine. So we have the following identity. The tangent of an angle is the same thing as the sine of an angle divided by the cosine of an angle. So this is one quotient identity. Quotient because we're dividing two things. And then the cotangent, again, is just the tangent flipped over. It's just the reciprocal. So if the tangent is sine divided by cosine, the cotangent is the cosine divided by sine. So here are our two quotient identities. And what I think I'll do is I'll stop here, and there's one more set of identities that we'll do in the next video, and then we'll do lots of examples using our identities.